Hi, this is Professor R.S. Patil, working as an assistant professor in the Department of Mechanical Engineering, Sinhagad Institute of Technology, Lonavala, Maharashtra. I have 13 plus years of experience in the teaching field in the Department of Mechanical Engineering. So finally, I am here. So I am going to deal with the mechanical engineering subjects. I am going to cover GATE syllabus and I'm going to solve the MCQ of GATE exams and also the other kind of competitive exams in the field of mechanical engineering, and also I'll be solving the numericals of academic exam also. It means these videos will be useful for those who are preparing for any competitive exams in the field of mechanical engineering, including GATE, and also it will be useful for those who are preparing for academic exams. I hope you are going to follow me and you are going to take use of it. Okay, so at first I have considered the syllabus application of thermodynamics. In that, so we are going to deal with the concept called psychometry. In that, we are going to deal with the properties of moist air, psychometric chart, basic psychometric processes. The syllabus seems to be one line, but we have a lot of concept we need to study and we need to understand. Okay, so before we start the actual syllabus, I would like to put some of the questions in front of you to have some clarity. Later we will go to the actual syllabus. Now the first question in front of you is that if you want to be comfortable in nature these days, on what device you are dependent on? Okay, so I can expect an answer from you. So these days we are dependent on fan, air cooler, air conditioning, heat pump, humidifier, dehumidifier. So these are the most common used devices these days. So if we are if we want to be comfortable. Okay, so the next question I would like to put in front of you is that does air conditioning means only cooling of air to lower temperature? The reason why I'm asking this question is there is a perception among the student is that air conditioning means lowering the temperature of the air. Does it means actually? So if does not mean, then what exactly the air conditioning means? What are the processes are involved in the air conditioning? Basically, air conditioning, in the air conditioning, we are going to deal with the temperature, of course, and we'll be dealing with the humidity and we'll be dealing with the air purification. These are the most common process which are adapted in the air conditioning process. So air conditioning means, it does not mean that the cooling of air to a lower temperature. It means it's not alone. So along with that, some other processes are there which are adapted in the air conditioning. The next question: what are the gases present in the atmosphere? So nitrogen and oxygen. So these two gases have got the lion's share in the atmosphere. Apart from nitrogen, oxygen, there is a argon, carbon dioxide, neon, helium, methane, krypton, nitrogen oxide, and hydrogen. All these gases are present in the atmosphere. Please remember, all these gases are present in the atmosphere, but nitrogen and oxygen have got lion's share. Okay, so I would like to put the next question in front of you is that now apart from all these gas, nitrogen, oxygen, argon, carbon dioxide, neon, helium, methane, krypton, nitrogen oxide, and hydrogen, apart from all these gases, the question is that do you think any important gas is missed in the list who has very important role in keeping us comfort or discomfort? The question is that apart from all these gases, is there any gas which is missed in the list who has got very important role in keeping us comfort or discomfort? Yes, yes, that is none other than the water vapor. The water vapor is treated as a gas which is present in the atmosphere. Its quantity in the atmosphere varies from place to place, varies from time to time, varies from season to season, but its quantity has got very important role in keeping us comfort or discomfort. For example, let's consider the two cases. If it is too low, it means that in the atmosphere, if the water vapor is too low, what happens, how do we feel? So definitely, if it is very less in the atmosphere, the sweat in your body evaporates easily into the atmosphere. Because of that reason, your body will be cooled. So because of that, you will be feeling cooler than the temperature. It means that you feel that the temperature of the atmosphere is too low, but it may not be the reason. The temperature may not be too low, but the reason is that the water vapor in the atmosphere is very low. Because of that, the sweat in your body evaporates easily into the atmosphere, and your body will become cooled. Your body will be cooled. That is the reason you will be feeling cooler than the temperature of the atmosphere. On the other hand, if it is very high, if it is the water vapor in the atmosphere, if it is very high, what happens with us? So the same, the mechanism works here. So if the water vapor is very high in the atmosphere, the sweat in your body cannot evaporate easily into the atmosphere. Then the sweat will remains on the skin of your body, so that you will be feeling hot and you will be feeling sticky. So the conclusion from this slide is that the water vapor, the quantity of water vapor has got very important role in keeping us comfort or discomfort in the nature. Okay, let's move to the next question. What is the value of atmospheric pressure? The value of atmospheric pressure is, you know, P equal to 1.01325 bar. It is the atmospheric pressure at sea level. In the psychometry, we are considering as a total pressure. Okay, so it will be useful while solving the numericals. I hope you are understanding the concept. Then the next question I would like to put in front of you is that, why do you feel so much discomfort when you visit coastal area like Mumbai, even though low temperature is recorded? The same question I would like to reiterate. What is that? I told you. So apart from all these the gases, one more gas is present in the atmosphere, that is the water vapor. So its quantity in the atmosphere has got very important in keeping us comfort or discomfort. If you visit the coastal area like Mumbai, the quantity of water vapor in the atmosphere is very high. Because of that reason, the sweat in your body cannot evaporate easily into the atmosphere. So what happens, the sweat will be remains on your body, and your body will not be cooled off. It means you are going to feel very hot, you are going to feel sticky. That is the reason, though the temperature is very less, because of very high water vapor present in the atmosphere, you will not be feeling comfortable if you visit the coastal area like Mumbai or any other places in the in India or in the world. Okay, now after putting all these questions and collecting some of the basic information, basic knowledge, I would like to go through the terminologies of psychometry. The first terminology that we must understand is the dry air. That we must understand the dry air. So the first what do you mean by dry air? I told you. So apart from all these gases, the one more gases is present in the atmosphere, that is water vapor. But if you don't consider the water vapor, then air becomes drier. Very simple definition of dry air is there: no water vapor present in the air. If there is no water vapor in the air, then that air is called dry air. Of course, all these gases will be there, all these gases together we are calling the dry air, but only one thing is that no water vapor present. But practically you won't get dry air in the atmosphere. Even the small quantity of water vapor present, but you won't get dry air. That means you cannot find the air which has no water vapor in the atmosphere. I hope you are understanding. What is the definition of dry air? The air which has no water vapor at all, zero amount of water vapor present in the in the air. Okay. Next, what is the next definition? What is the next terminology of psychometry? Is called moisture. Moisture means, of course, you are finding the moisture in the atmosphere. It means it is the combination of all these gases, and also there will be the present of water vapor. Okay. So the air that has water vapor present in it, that is called the moisture. Moisture is the combination of dry air plus water vapor. It is called moisture. So practically in the nature we are finding the moisture irrespective of the quantity of water vapor, but we are finding the moisture. So moisture is defined as it is the combination of dry air and the water vapor. Okay. Next, what is moisture? See, what is the dry air? Dry air, the air which has no water vapor at all. What is the moisture? Moisture means the air which has the water vapor. Then what do you mean by moisture? Moisture is nothing but water vapor. Moisture is nothing but water vapor. The another name of water vapor you can say the moisture. Okay. Now after learning the three definitions, please try to understand. Remember the three definitions. The first definition is the dry air. I already told you, in the atmosphere there are so many gases are there. Keep that all the gases one side. The one more gas is there, that is the water vapor. If you don't consider the water vapor, then the air becomes dry air. If you consider the water vapor, then air becomes moisture, and water vapor is also called as the moisture. Okay. So now we are moving towards very important definition of psychometry. On this definition, on this particular terminology, all the concept of psychometry is involved. Please try to understand the concept which I am going to teach. Okay. Let us let us say this guy has a maximum capacity of holding 10 bricks. He can hold 10 bricks. It means that up to 10 bricks he can hold without any trouble. Up to 10 bricks. From 1 to 10 he can hold without any trouble. But what is the maximum capacity of holding? The maximum capacity of holding is 10 bricks. He can hold 10 bricks. Okay. So what happens if I give him 11 bricks? That means one, if I put on his hand one brick extra, then what happens? So this is the concept. With this concept, I would like to move to the next definition, that is, let us replace that guy with the dry air. I already told you what is the dry air. Dry air which has no water vapor at all. But the question is, can dry air hold the water vapor within it? Like that guy was holding the 10 bricks. The capacity of holding he was 10 bricks. He was holding 10 bricks, na, like that. So let us replace that guy with the dry air. He was holding 10 bricks. Now can dry air hold the water vapor within it? Yes, it can hold the water vapor within it. The next question is, if yes, if dry air can hold the water vapor within it, the question is that 1 kg of dry air can hold how much amount of water vapor at max? This is very important, very important. If I can hold the same question with the previous slide, is that if I can hold the brick, then the question how much bricks I can hold at max? The same question I would like to put with the dry air. If dry air can hold the water vapor, then the question is that 1 kg of dry air can hold how much amount of water vapor at max? Okay, the answer is depends on temperature. It means the question which we asked is the incomplete question, because you won't get the specific answer, because the question is incomplete, because the answer depends upon the temperature. Okay, let's move to that. This is the table that I am going to refer in order to deal with so many definition, in order to have crystal clear about some of the terminologies of psychometry. Please try to understand. I will ask once again. So can dry air hold the water vapor within it? Of course, we have defined the moist air. Moist air is nothing but dry air plus water vapor. It means dry air can hold the water vapor. There is no doubt in that. But how much, one, if you consider the 1 kg of dry air, the question is that 1 kg of dry air can hold how much amount of water vapor at max? What is the capacity of holding the water vapor by 1 kg of dry air? But you won't get the specific answer to this because it depends on the temperature. So I have collected some experimental data in order to understand concepts and terminology very clearly. Let's say, so instead of that, I will just modify the question. 1 kg of dry air at 10 degrees Celsius, 1 kg of dry air at 10 degrees Celsius, how much amount of water vapor it can hold at max? Now the specific answer is 0.0076 kg of water vapor it can hold. That is 1 kg of dry air at 10 degrees Celsius, it can have a 0.0076 kg amount of water vapor at max. Like that, if I increase the temperature to 12 degree, if I ask the same questions, so 1 kg of dry air at 12 degrees Celsius, how much amount of water vapor it can hold at max? The specific answer is 0.0087 kg of water vapor it can hold at max. Like that, if I increase the temperature from 12 degrees Celsius to say 20 degrees Celsius, if I ask you the same question, 1 kg of dry air at 20 degrees Celsius, how much amount of water vapor it can hold at max? The answer is 0.0147 kg of water vapor. The conclusion which is made from this table is that, what is the conclusion? Tell me. The conclusion is that if we increase the temperature of the air, the holding capacity of water vapor will be increased. So this is the table that I am going to refer in order to define some of the terminology. Very, very important. Very, very important. Please try to understand. Okay. Now let's go to the next slide. This is very, very important terminology in the psychometry in order to understand the all the terminology of psychometric process. Very, 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 very important. According to me, very, very important. Please try to understand. That is the reason I'm making. So if you go through the book, there will be the one line sentence, but you won't understand. You may by it, but the further concept will not be understood by you. That is the reason I am taking lot of time in order to convey the clear concept of the word called saturated air. Okay. Now there is a 1 kg of dry air at 18 degrees Celsius. Suppose if it has got the 0 kg of water vapor, then what is the air called? Dry air, because it has no water vapor at all. Okay. Then the next question is 1 kg of dry air at 18 degrees Celsius, how much amount of water vapor it can hold at max? So the answer is 0.0129 kg water vapor it can hold at max at 18 degrees Celsius. Okay, the minimum is 0, maximum is 0.0129 kg at what temperature? 18 degrees Celsius by 1 kg of dry air. But how much actually it is carrying? 0.0129 kg. The question parallelly I would like to put the question. For example, so I have a capacity of heating 10 rotis. It does not mean that I am always going to heat the 10 rotis. Like that I will take the point previous. 1 kg of dry air at 18 degrees Celsius, if it has a 0 kg of water vapor, that is called dry air. So at max, how much amount of water vapor it can hold? It can hold 0.0129 kg. But how much actually it is carrying? It is carrying 0.0129 kg. Please try to understand. The air is having, or air is holding 0.0129 kg of water vapor, which is equivalent to its maximum capacity. I will give you some time. Please try to understand. I will take this. Okay. So air is holding or air is having 0.0129 kg of water vapor, which is equivalent to its maximum capacity at that particular temperature. If it is so, then that air is called saturated air. Then that air is called saturated air. Okay, if you have not understood, I am going to take the another example. Say the 1 kg of dry air at 10 degrees Celsius. Okay, if air is carrying 0 kg of water vapor, then what it is called? It is called dry air. Okay, now the question is 1 kg of dry air at 10 degrees Celsius. So how much amount of water vapor it can hold at max? The maximum capacity is 0.0076 kg. Now question is actually how much amount of water vapor it is carrying? It is carrying 0.0076 kg. It means that the air is having 0.0076 kg of water vapor, which is equivalent to its maximum capacity at that particular temperature. So such type of air is called saturated air. So how do you define the saturated air? Saturated air is the air having the water vapor which is equivalent to its maximum capacity at that particular temperature. That is called saturated air. Or you can also define saturated air means air which has got maximum amount of water vapor, maximum amount of water vapor at that particular temperature. Okay, so to have some more clarity, let's go to the next. Okay, now again 1 kg of dry air at 20 degrees Celsius. Okay, so if it has a 0 kg of water vapor, what it is called? If there is no water vapor, what it is called? Dry air. Okay, now the question arises 1 kg of dry air at 20 degrees Celsius, how much amount of water vapor it can hold at max? That is 0.0147 kg of water vapor it can hold. But how much actually the air is carrying? Let us see. The air is carrying or air is holding 0.0121 kg. Please try to understand. It means that the air is having or air is holding 0.0121 kg, which is less than the maximum capacity, which is less than its maximum capacity at that particular temperature. It means this type of air is called unsaturated air. This type of air is called unsaturated air. What is the unsaturated air? Air is having the water vapor, but it is less than its maximum capacity at that particular temperature. Okay, now we will understand some more concept on the same slide. The question is that still how much vacancy is there? Please try to understand. What is saturated air? Saturated air means air which has got maximum amount of water vapor. It means what is the vacancy? Vacancy, there is no vacancy. The water vapor is filled with the dry air. Here the unsaturated air means the air is having the water vapor which is less than its maximum capacity at that particular temperature. Then still how much vacancy is there as per this slide, as per this reading? Okay, at 20 degrees Celsius 1 kg of dry air at most it can hold 0.0147 kg, but actually it is carrying 0.0121 kg. So what is the vacancy? What is the vacancy present in that? The vacancy present in that is, please try to understand, the maximum was 0.0147 minus actually present is 0.0121. The difference of that is 0.0026 kg. It means this much amount of water vapor still you can add in that air. Still you can, this much of amount of water vapor there is a vacancy, still you can add in that air. So if you add this much amount of water vapor in that air, then the air becomes saturated. Okay, so I am using the word called vacancy. Please try to understand. If you call the air is saturated air, then there is no vacancy for water vapor. If you call the air is unsaturated air, it means that the unsaturated air which has the water vapor but which is equivalent, which is less than its maximum capacity at that particular temperature. So always there will be vacancy in the unsaturated air. You can add some amount of water vapor to that. So as per this reading, the vacancy is 0.0026 kg. So still you can add that much amount of water vapor to that air so that the air becomes saturated. I hope you are understanding. So what is the difference between saturated air and unsaturated air? Saturated air means air which has got a maximum amount of water vapor at that particular temperature, or saturated air which has got water vapor which is equivalent to its maximum capacity, which is equivalent to its maximum capacity at that particular temperature. Okay, so let's go to the next slide. If water vapor is added to the saturated air, then what happens? Please try to understand. What is the saturated air? Again, I will explain. 1 kg of dry air at 20 degrees Celsius. If it is having the 0 kg of water vapor, what it is called? Dry air. So, what is the amount of water vapor it can hold at max? It can hold 0.0147 kg of water vapor. It can hold at max. The maximum capacity of holding the water vapor at 20 degrees Celsius is 0.0147 kg. Okay, now actually how much it is carrying? The air is carrying 0.0147 kg. Please try to understand. It means that air is having the water vapor which is equivalent to its maximum capacity at that particular temperature. It means the air is saturated air. Air is saturated air. The question is that if water vapor is added to the saturated air, means air is saturated air. Okay, there is no vacancy at all for the water vapor. You cannot add the water vapor. You cannot accommodate the water vapor in that because already vacancy is filled. Because you are calling the saturated air. Air becomes saturated with water vapor. But if I want to add the water vapor still I want to add 1 gram of water vapor to saturated air. What happens with that 1 gram? Is there any probability that 1 gram also will be accommodated? Because the air is already saturated, because the air has no vacancy at all to accommodate the water vapor. The question is that if water vapor is added to the saturated air, then what happens? For example, I am adding 1 gram extra. What will happen with that 1 gram means that 1 gram will be converted into dew or fog, like this will be converted into dew or fog. So it cannot be accommodated at all. It can be converted into, if you want to add it forcefully, that extra amount will be converted into dew or fog on the surface. Okay, next question. Please try to understand. Very important question are there. So just to define the saturated air and unsaturated air, I am taking lot of time here, because if you want to be perfect proficient in the field of psychometry, you need to understand these examples. Later very easily you can define the terminology of psychometry and you can understand the further concept. Okay, the question is that if you cool the saturated air, then what happens with the water vapor? Is there any vacancy creates? Okay, first of all we will take the saturated air. Then we are going to cool the saturated air to a lower temperature. Then we will observe what will happen with the water vapor step by step. I will consider the saturated. Okay. So 1 kg of dry air at 20 degrees Celsius is there. Suppose if it has a 0 kg of water vapor, what it is called? It is called dry air. The question arises at 20 degrees Celsius, by 1 kg of dry air, how much amount of water vapor it can hold at max? The answer is that 0.0147 kg of water vapor. Its maximum capacity. Actually, the air is carrying how much amount of water vapor? It is carrying 0.0147 kg. It means it is equivalent to its maximum capacity at that particular temperature. So this air is called saturated air. This air is called saturated air. Then now question arises, if you cool the saturated air, it means that I am going to cool this saturated air to 19 degrees Celsius or 18 degrees Celsius or 17 degrees Celsius or 16 degrees Celsius. Then what happens with the 0.0147 kg of water vapor? That means parallelly I am going to give the example. For example, there is a classroom. There are 20 benches are there. 20 students are seated. It means room has become saturated. 20 benches are there, 20 students are accommodated, room is saturated. Now I am going to remove the 2 benches from it. I am going to remove the 2 benches from it. Then the question arises, what happens with the 20 students? Whether the 20 students will be remains in the classroom or 2 students are removed from the classroom. The same concept here. The same concept here. The 1 kg of dry air at 20 degrees Celsius is holding 0.0147 kg, which is equivalent to its maximum capacity at that particular temperature. It means air is now saturated air. It's not a dry air, it is saturated air. It has got maximum amount of water vapor. Now I am going to cool this to a lower temperature. The question arises, what happens with this 0.0147 kg of water vapor? Let's see. So I am going to cool this to 18 degrees Celsius. So I am cooling the air from 20 degrees Celsius to 18 degrees Celsius. Which air? I am cooling saturated air from 20 degrees Celsius to 18 degrees Celsius. So I am going to ask the question is that what happens with the 0.0147 kg of water vapor? Is it changes? Is it will be remains constant? It will be remains constant. In order to answer to that, first of all we will understand at 18 degrees Celsius what is the maximum capacity of water vapor. The maximum capacity of water vapor is 0.0129 kg. At 18 degrees Celsius, at most it can hold 0.0129 kg, but the amount of water vapor present is 0.0147 kg. Then the difference what happens? So 18 degrees Celsius cannot hold 0.0147 kg. At most it can hold 0.0129 kg. So what happens with the difference? What happens with the difference? Just say the difference is 0.0147 minus 0.0129. What happens with this? Where this water vapor will be going? So this difference will be condensed or this difference will be removed. This difference of water vapor will be removed from the system, will be removed from the air. This difference, that means this difference of amount of water vapor is condensed into water. That I will explain in detail in the next slide. In the next slide, please try to understand the mechanism how it is going to work. Okay, so now for example I am going to take that from 18 degrees Celsius to 16 degrees Celsius. Look at this. Okay, so the while bringing the air from 20 degrees Celsius to 18 degrees Celsius, so how much amount of water vapor is removed? The amount of water vapor is removed is 0.0147 minus 0.0129. The whatever the difference it is there, that much amount of water vapor is removed. Okay, now 18 degrees Celsius, at 18 degrees Celsius what is the air called? Thus again it is saturated air. Is there any vacancy created? No vacancy created. The 20 degrees Celsius, it was also saturated. 18 degrees Celsius, it is also saturated. Now we will go to the 16 degrees Celsius. We will go to the 16 degrees Celsius. Now I will ask the same question, that is 0.0129 kg. What happens with the 0.0129 kg? Whether it will be remain same? Now to answer to that, for 16 degrees Celsius at max how much amount of water vapor it can hold? It can hold 0.0114 kg. So how much amount of water vapor is there at 18 degrees Celsius? 0.0129 kg. Is it possible? At 16 degree at max it can hold, it can hold 0.0114 kg. But the difference, what will happen with the difference? What is the difference? The difference is that 0.0129 minus 0.114. What will happen with the difference? So this difference, this much difference, whatever the difference it is coming, that amount of water vapor is condensed into saturated liquid or liquid. that amount of water vapor is removed. After removal at 16 degree, again the air is called saturated air. There is no vacancy created. Okay, so in order to have the concept very clearly, I will go to the next slide. So the answer to the question is that if you cool the saturated air, then what happens with the water vapor? Is there any vacancy created? No vacancy creates. No vacancy creates. Air, saturated air will become saturated air. Saturated air will become saturated air. So if you keep on cooling the saturated air to its lower temperature, there is no vacancy creates at all. For example, air is at 20 degrees Celsius, it is a saturated. If you go to the 19 degree, again it is saturated. 18 degree, again it is saturated. 17 degree, again it is saturated. 16 degree, again it is saturated. But as the holding capacities keep on decreasing, as you decreasing the temperature, the holding capacity also keep on decreasing. So whatever the difference is there, that difference will be removed out of the air in the form of liquid, or the water vapor is condensed back to the liquid. So you must understand this concept. You must understand this concept. So in order to have, if you don't understand, I will explain in the next slide. Try to understand. What is condensation or removal of water vapor or dehumidification? This dehumidification word I am not going to use at this stage. I will be using this word at the later part of the concept. I am going to understand you what is the condensation or removal of water vapor. Okay, let's see. Again, I am going to take the 1 kg of dry air at 20 degrees Celsius. Means dry air means it has a zero amount of water vapor. Now the same question arises, what is the amount of water vapor it can hold at max at 20 degrees Celsius? Its maximum capacity is 0.0147 kg. Okay na? Its maximum capacity is 0.0147 kg. Actually, how much amount of water vapor it is carrying? It is carrying 0.0138 kg. Please try to understand. Means air is having the water vapor which is less than its maximum capacity at that particular temperature. So what is this air called? This air is called unsaturated air, because still there is a vacancy is there. The water vapor is not completely filled in the air. So this is unsaturated air. Now I will cool this air to a lower temperature, to 19 degrees Celsius. Okay. So I am going to cool this air to a 19 degrees Celsius. The question arises, what happens with this 0.0138 kg? In order to answer that, first we need to understand at 19 degrees Celsius what is the maximum capacity. The maximum capacity is 0.0138 kg. So the maximum capacity is 0.0138 kg. So now question arises whether the 0.0138 kg water vapor which was there at 20 degrees Celsius, it will be remains 100%, it will be remains. You can accommodate whole amount of water vapor, nothing will happen, because 19 degrees Celsius can hold 0.0138 kg of water vapor. Now what happened? Happened is, it was a unsaturated air at 20 degrees Celsius. Now it has become saturated air. Now it has become saturated air. Okay. Now I am not going to stop here. I am going to cool this air again to 18 degrees Celsius. Now I will check what happens with 0.0138 kg of water vapor. So I am going to check. So I am going to cool the air from 19 to 18 degrees Celsius. The same question I will ask, whether 0.0138 kg of water vapor it will be remains same. Is there anything happens with 0.0138 kg? Whether it can be accommodated at 18 degrees Celsius? In order to answer that, I need to understand at 18 degrees Celsius what is the maximum capacity. The maximum capacity is 0.0129 kg. But how much amount of water vapor is there? 0.0138 kg. So at 18 degrees Celsius, at most it can accommodate 0.0129 kg. But how much amount of water vapor was there? 0.0138 kg. But at 18 degrees Celsius, at most, how much amount of water vapor it can hold? 0.0129 kg. So what will happen with the difference? That is 0.0138 minus 0.0129 is equal to 0.0009 kg water vapor. Where it will be? Where it has gone? So this much amount of water vapor, has been condensed, has been removed. Has been condensed means this much amount of water vapor has been condensed to liquid. This much amount of water vapor is removed out of the air, has been condensed to liquid. It means the condensation process is occurred. Please try to understand. Condensation process is occurred. Condensation process means it has the initial point and end point. It means 0.0009 kg of water vapor is condensed. Condensed means where it has started. This process is started at what temperature? This process is started at 19 degree and ended with 18 degree. Do you think that the condensation has started at 20 degree? Condensation has started at 20 degree? No, it has started at 19 degree and it is ended at 18 degree. So during this condensation process, how much amount of water vapor is condensed? 0.0009 kg of water vapor is condensed. That means it has water vapor has become liquid. It is separated out of the air. So you must understand. This is very important question, very important concept in order to understand the next terminologies. I hope what is the condensation, what is or removal of water vapor means. Condensation means the water vapor will be condensed to liquid. So where it has started? At this example, at 19 degree it has started. Okay, where it has ended? At 18 degree. During this condensation process, how much amount of water vapor is condensed or removed? That is 0.0009 kg of water vapor is removed. So you must understand this. So if it is possible, while defining the next terminology, again I am going to explain this. Now the question arises, when does the water vapor begins to condense in the air? So the previous question, why it was not started at 20 degree, why it is started at 19 degree? The reason was that the 20 degree, at 20 degree it was not saturated air, it is unsaturated air. When you go to the 19 degree, it has become saturated air. When you cool the saturated air, then water vapor in the air begins to condense. So the answer to this question is, when does the water vapor begins to condense in the air? The answer is that when the saturated air is started cooling to its lower temperature. If you cool the unsaturated air, the water vapor will be remains constant till it becomes saturated air. But if you cool the saturated air to lower temperature, then the water vapor starts condensing. Okay. Now, in the same way, if you heat the saturated air, then what happens with the water vapor? Is there any vacancy creates? Please try to understand. So in the reverse way. So I have taken 1 kg of air at 18 degrees Celsius. If it has a 0 kg of water vapor, what it is called? Dry air. So what the maximum capacity? 0.0129 kg. So how much amount of water vapor it is carrying? 0.0129 kg. Now tell me, air is carrying the water vapor which is equivalent to its maximum capacity at that particular temperature. This is called saturated air. Now I am going to heat this air to a higher temperature. So let's say 18 degrees Celsius to 19 degrees Celsius. Now the question arises whether 0.0129 kg, what happens with that? Whether it can be accommodated, the full amount of water vapor can be accommodated at 19 degrees Celsius. In order to answer to that question, let me check what is the maximum capacity, that is 0.0138 kg. The maximum capacity is 0.0138 kg, but the amount of water vapor present is 0.0129 kg. It can be easily accommodated. So now air has become what? Unsaturated. Now vacancy is created or not? Yes, vacancy is created. How much vacancy is created? That is 0.0138 minus 0.0129. The difference still you can add in that air. Okay, now I am going to increase the temperature 19 to 20 degrees Celsius. Can I accommodate 0.0129 kg at 20 degrees Celsius? In order to answer to that, I will check at 20 degrees Celsius what is the maximum capacity, 0.0147 kg. What is the air is carrying, 0.0129 kg. It can be easily accommodated. So is there vacancy created or not? Yes, of course vacancy created, which is more than the previous at 19 degrees Celsius. How much vacancy is created? That is 0.0147 minus 0.0129. That much of vacancy is created. So why the vacancy is being increased? Because as you keep on increasing the temperature, the holding capacity of water vapor is increased. But it is not the case of lowering the temperature. Understood? Okay. Now the question arises. Whatever I defined, the saturated air, unsaturated air, I have taken the reference or the reading from this table, which is the experimental data. The question arises, to identify whether the air is saturated or unsaturated, should we remember this list? This is very important question. अगर मेरे को if I want to call the air is saturated or unsaturated at that particular temperature, so I have defined, how I have defined? I told at this temperature, if this much amount of water vapor is there which is equivalent to its maximum capacity, then the air is called saturated. If it is less than its maximum capacity, then air is called unsaturated. Does it mean that I have to remember the capacity of air at but particular temperature? Is it possible? Is it possible? So the answer is no. You need not to remember the maximum capacity of holding the water vapor by the dry air at that particular temperature. Then question arises, how to identify whether the air is saturated or unsaturated? So it is a very simple way. Later we are going to understand that. But so in order to understand the concept of saturated, unsaturated, I have taken the reference of this table. Okay, you need not to remember at all. But if at all, if you want to know, for example, at 12 degrees Celsius, what is its maximum capacity? If you want to know, then that is also possible, but you are not supposed to remember at all. So how to remember the question? How to identify the maximum amount of water vapor that air can hold at a particular temperature in the psychometric chart? So I'm going to introduce the psychometric chart. This is what the psychometric chart, where you are going to find the properties of moist air. What is moist air? Moist air is the combination of dry air and water vapor. Okay. So for example, what is the objective of this slide? I want to know at that particular temperature what is the maximum amount of water vapor it can hold. I need not to remember at all to define saturated air, unsaturated air. I just explained with that data because you need to understand the clear concept of saturated, unsaturated air. Okay. So for example, this is first of all you should understand, this is called saturated curve. The last curve is the saturated curve. I'm not going to tell you all the lines, all the curves at a time. So as the time comes, so I'm going to introduce one by one. So the last curve is called saturated curve. Now I want to know at 25 degrees Celsius, at 25 degrees Celsius, 1 kg of dry air, how much amount of water vapor it can hold. So I have taken a look at this. At 25 degrees Celsius, I have drawn the line and up to the saturated curve. From that point, so I have drawn towards that water vapor curve, water vapor scale. This is the maximum amount of water vapor. This is the maximum amount of water vapor. The 1 kg of air at 25 degrees Celsius it can hold. It can hold. And what is the minimum? Minimum is 0. Minimum is 0. So 1 kg of air at 25 degrees Celsius, if it is holding 0 kg of water vapor, then that is called dry air. If it is holding 0.020 kg of water vapor, it is called saturated air. if it is holding in between 0.020 and 00 any amount, then it is called unsaturated air. Like that, if I take the next example, for example 14 degrees Celsius, from 40 degrees Celsius I have to reach to the saturated curve. From the saturated curve to the right side I have to go to the water vapor curve. Water vapor. So if the at 15 degrees Celsius, if it is holding the 0.0 kg, then it is called dry air. If it is holding 0.010 kg, then it is called saturated air. In between 0.010 and 00, if it is holding any amount, then it is called unsaturated air. For example, let me to take the next example. I am going to take the 28 degrees Celsius. I would like to ask, at 28 degrees Celsius how much amount of water vapor it can hold. So from 28 degrees Celsius I have to reach to saturated curve. From the saturated, first I have to reach to saturated curve. From the saturated curve I have to go to the water vapor scale. This is the maximum amount of water vapor in terms of kg. This is the maximum amount of water vapor, that is 0.024 kg of water vapor. It can be holded by 1 kg of dry air at 25 degrees Celsius, and minimum is again 0 at 28 degrees. If it is holding 0, it is dry air. If it is holding 0.024 kg, it is saturated air. In between 0.024 and 0, if it is holding any amount, then it is unsaturated. Okay, so in this way I can find at any particular temperature what is the maximum amount of water vapor it can hold at max. Okay, but in order to define the saturated air and unsaturated air, you need not to remember at all. You need not to remember even. So there are some other methods are there to say whether the air is saturated or unsaturated. Okay, now mass of water vapor when air is unsaturated and saturated. So I am going to denote some terminologies. First of all, we will identify again saturated and unsaturated. Look at this. Okay, 1 kg of dry air at 18 degrees Celsius is there. If it is having 0 kg of water vapor, what it is called? Dry air. Then what is the maximum capacity at 18 degree? It is 0.0129 kg. Then how much actually it is carrying? That is 0.0121 kg it is carrying. So please try to understand which is less than its maximum capacity at that particular temperature. It means this air is unsaturated air. This air is unsaturated air at 18 degrees Celsius. But I will take the same air at 18 degrees Celsius. Okay, so what is the maximum capacity? Already know, at 18 degrees Celsius 0.0129 kg. So what it is carrying? That is 0.0129 kg of water vapor it is carrying. Then what is the difference between first and second one? The first one is unsaturated air at 18 degrees Celsius. Second one is saturated air at same 18 degrees Celsius. Understood? Then how to denote some of the variables for saturated air and unsaturated air at a particular temperature. The first, look at this. Mass of water vapor mv when air is unsaturated. But when the same air becomes saturated, so how do you define the mass of water vapor? MVS. S means saturated. That is mass of water vapor when air is saturated. So what is the difference between MV and MVS? MV is the mass of water vapor when air is unsaturated, but mass of water vapor when air is saturated, that is denoted as MVS. Thus, in the same way, partial pressure of water vapor PV when air is unsaturated, but when the same air becomes saturated, we are going to define partial pressure of water vapor when air is saturated, that is PVS. P suffix VS. S stands for saturated. In the same way, density of water vapor rho suffix V when air is unsaturated, but when the same air becomes saturated, we are denoting rho Vs, that is density of water vapor when air is saturated. So you must understand this. You must understand this. So whatever I am explaining in this video. So it might cover a very less syllabus of the your whole syllabus. but in order to understand the whole concept, you can say this is the strong fundamental concept which we need to understand, try to understand again and again, you go through it, try to understand. Okay, we are coming to the last slide. Whatever we have understood in this slide, I will make the revision within a few minutes. The first terminology that we have understood is the dry air, the air which has got the air which has no water vapor at all, that is called dry air, and practically it is impossible to get the dry air in the atmosphere, so some amount of water vapor it will be always there. What is moist air? It is the combination of air plus water vapor. If you consider the water vapor, it becomes moist air. So what is moisture? Moisture is nothing but water vapor. Then what is saturated air? The air which is having the water vapor which is equivalent to its maximum capacity at that particular temperature. Means air which has got a maximum amount of water vapor at that particular temperature. In simple, there is no vacancy at all for water vapor. Means already water vapor is fully filled with the air. There is no space for any further amount of water vapor. That is saturated air. What is unsaturated air? Unsaturated air means air is having of course the water vapor, but which is less than its maximum capacity at that particular temperature. Then what happens what happens with water vapor when saturated air is cooled? This is very important. If you say air is saturated at 20 degrees Celsius, if you cool to 19 degree, what happens with the water vapor? If you cool to 18 degree, what happens with the water vapor? If you cool to the 17 degree, what happens with the water vapor? So definitely the water vapor will be condensed, will be removed from the air, because if you cool to a lower temperature having the lower capacity, higher temperature having the higher capacity. If you go to the lower capacity, then the difference of water vapor will be condensed to liquid or removed from the air. Okay, so but the saturated air will be remain saturated air at the lower temperature also, that you understood from the previous slide. Condensation or removal of water vapor, that you understood. Now what happens with the water vapor when saturated air is heated, that you understood. How to find the maximum amount of water vapor at a particular temperature using the chart, that you understood. How to denote some variables for unsaturated air and saturated air, that you have understood. So these are the concept that you have understood from this video. Okay, so thank you very much, and I will be continuing with the further concept of psychometry. I hope you have understood, you have enjoyed with the concept of psychometric process, psychometric concept. Okay, thank you very much.